Hi everyone, today we're talking about congruence. Now earlier in the chapter we talked about angles being congruent. Congruent is just a fancy way of saying equals. It's like the geometry way of saying equal. So today instead of talking about congruent angles, that'll be included in it, but we're going to be talking about congruent polygons. They have the same size and shape, which make them literally identical shapes to each other. Like identical twins, exactly the same. Everything about them is the same. Their corresponding angles and sides are congruent. And remember, corresponding meant they're in the same position. So angles in the same position, or sides that are in the same position, or that match, they are congruent to each other. So if I'm looking at our very first triangle, set of triangles here, I have triangle ABC is congruent to triangle DEF. And what this tells us is that A being in the first position and D being in the first position, and if you look at the picture it also applies, they each have the same number of loops on the triangles, on that angle. They each have 3 loops, which mean those angles are the same. If I'm looking at angle B and angle E, those are the same. They have 1 loop, so they match. And then similarly, C and F have the same number of loops, so they match. The sides also have markings that indicate that they have the same length. Like B, C, and EF each have 1 marking. DE and AB each have 2, and then AC and DF each have 3. So the congruent statement says triangle ABC is congruent to DEF. Could I write that differently? Sure. What if I started with C? Triangle CBA, that's the same as triangle FED. So similarly, we could write that, and it just means the same thing. So we're going to try one of these on our own. It says write a congruent statement for the following polygons. So now I've just given you angle measures that are the same, or side measures that are the same. But we have to identify what shape we have. It's a 5-sided figure, so it's a pentagon. So we'd say pentagon, or pent is fine. Pentagon, and let's just keep it easy on the first one. Let's call it A, B, C, D. E is congruent to pentagon. I guess I don't really need the A there. And now let's figure out where A matches up. A is in between the 2 sides that each have 2 hash marks, so is N. So N must go first. Then I chose to go clockwise, B, C, D, E, and we can do that as well here. Now, it would also work NSWVP or NPVWS. So what you're going to do is I did it clockwise, and then I did it clockwise again. You want to go around your shape, naming all the vertices, and that tells us what angles and what sides go together. Now, a question you will be asked is, I'm going to give you shapes that are congruent, meaning they're equal. So that tells you so much. Everything about them is identical. And then you're going to be asked to solve for variables that are missing in the picture. So the first thing you're going to do, it says R and H in this particular one. So I'm going to have R, which is a side length, which matches with the 15. So I'm going to set up a little equation. 5R minus 20 equals 15. So I'm going to add 20. So I have 5R equals 35. And then I just solve for R, divide by 5. R is equal to 7. So I've solved for my first variable. The second one is H, and it is in an angle position. Now I look over here, that's the angle it matches with, because N and F match, but unfortunately, I don't see an angle measure there. So I have to be creative. If these two are 71, makes an isosceles triangle, but more importantly, they have to add up to 180 degrees. So I'm going to have to do a little bit of work here. 180, take away 71, take away another 71. So let's just do that on our calculator quickly. So 180 minus 71, 180 minus 71 minus 71 again, I'm left with 38. So that means angle F is 38 degrees, which helps us because 2H is also equal to angle F, 38. So then we divide by 2. 38 divided by 2, which is 19. We're going to repeat the process. Okay, in the next shape, I have two quadrilaterals. ABCD is congruent to quadrilateral JKLM. And actually, I have to change some of these letters. Instead of H, I have an N here, so there's a little typo there. Find those missing variables. We're going to repeat the process like we did with the triangle. So I have 6r plus 12. What's it going to match with on the other? Like, these shapes are literally congruent to each other or equal. So I'm going to set up a little equation, 6r plus 12 equals 102. And then I'm going to subtract 12, subtract 12. So we have 90, and then I'm going to divide by 6. So r is equal to, so 90 divided by 6, 15. Now the second one, it requires a little bit more work. 4n matches with D, so D matches with M. M's here, and I don't see an angle measure, so I have to get creative. Well, I know in a quadrilateral, there's 360 degrees, because there are 4 sides. And we've already used 140 and 140. So now I'm down to, so 360, take away 140, take away 140 again, I'm down to 80 degrees. Now, this angle D is not 80 degrees, but we have to split it between two angles. So that means 80 divided by 2 would make each of these angles 40 degrees. So now I have 4n is going to be equal to 40 degrees. Divide by 4, and this is it, guys. Grand finale, n is equal to 10.